Alright, so this is video 2 of section 5.1, operations with polynomials. This video is going to be all about our exponent rules that we learned in Algebra 1 that none of you remember. So first thing we're going to do is go through the exponent rules, and then we'll look at a few examples. The examples are going to be a little bit harder than what you saw in Algebra 1, but that's because you're in Algebra 2 now. Okay, so the first property of exponent rules is our product of powers. What that exponent rule says is when you multiply two terms with the same bases, you just add their exponents. Okay, so for example, if I had x squared times x to the third, I add my exponents and I would get x to the power of 2 plus 3 or x to the power of 5. Okay. Similarly, my quotient of powers says if I divide two terms with the same base, I subtract the exponents. Okay, so if I had x to the power of 3 divided by x to the power of 2, that would become x to the power of 3 minus 2 or x to the power of 1. Okay, these are the two of the properties that we'll see most often, but we do have a whole list of other properties. They're also included on that little quarter slip of paper that I gave you in class yesterday and told you to put in your notebooks. I have a couple extra that I can give if you lost yours in the last 24 hours. Just ask me tomorrow in class. The next exponent rule that we're going to look at are negative exponents. So when you have a negative exponent, to get rid of that negative exponent, you move the term under 1. Or if it's already in the denominator, you move it up. Okay, so for example, if I had x to the power of negative 2, to get rid of that negative exponent, I would put 1 over x to the power of positive 2. Okay, similarly, if it was 1 over x to the power of negative 2, it's already in the denominator. I just move it up, and it becomes x to the power of positive 2. So you essentially just flip it. If it's on the top, you move it to the bottom. If it's on the bottom, you move it to the top, and you change the sign of the exponents. Another one that we're going to see a lot is called power of a power. Okay, and that occurs when you have an exponent that's raised to another power. When you have a power to a power, for example, x squared to the power of 3, you simply multiply those exponents. So x to the power of 2 times 3. 2 times 3 is going to give us 6. So that's x to the power of 6. Okay. The last three exponent rules that we have are power of a product, power of a quotient, and our zero power. Okay, so power of a product says if we have two things being multiplied together to some power, that power goes to everything in those parentheses. For example, if I had xy to the power of 2, I would distribute that second power to the x and the y, and that would give me x squared times y squared. Similarly, with quotients, it does the same thing. If you have a quotient to some power, it goes to both the numerator and the denominator. Okay, so for example, if I had x over y to the power of 2, that would give me x squared over y squared. Okay, now when we have a negative exponent on the outside, to get rid of that negative, we flip our numerator and denominator and then distribute it. Okay, so if I had, let me switch colors real quick. If I had xy to the power of negative 2, I would flip it to y over x first, and then distribute that second power, giving me y squared over x squared. All right, remember negative exponents always flip from numerator to denominator and denominator to numerator. The last exponent rule we have is our zero power. Anything to the power of 0 is just 1. So no matter what it is, it's always going to equal 1. So even if I have something really ugly like 1,447 x squared y to the power of 31, if I take that to the power of 0, that's a 0, not a u, it's just going to equal 1. No matter what, anything to the power of 0 is just 1. Okay, so the last thing that we're going to do is just look at a couple examples using these different exponent rules. But before we do that, we need to talk about what exactly it means for something to be simplified. So how we know we're done using our exponent rules, how we know that our monomial is as simple as it can be. Okay, so a monomial expression is in simplified form when there are no powers of powers, meaning you have no parentheses and exponents on the outside. Each base appears exactly once, so you don't have x's in the numerator and denominator. All fractions are in simplest form, so you don't have something like 2 over 4. You would simplify that to 1 over 2. And there are no negative exponents. Remember, you always want to get rid of those negative exponents by flipping your fraction. Okay, so now we're going to use these rules to simplify a few expressions. Now, when we simplify these expressions, we're kind of going to think about our order of operations. This one, we don't have to worry about as much because it's just multiplication. Okay, so I'm going to look at my constant or my coefficients first. So my coefficient here is 2. My coefficient here is 3. So 2 times 3, because this is multiplication, is going to give me 6. And because this is multiplication, I am going to be adding my exponents. So I'm going to add my a's with my a's, b's with b's, c's with c's. So negative 2 plus 3, negative 2 plus 3 is going to give me a positive 1. Now, next I'm going to look at my b's. The only b I have is b squared, so I'm going to leave it as b squared. And then I look at my c's. Again, the only c I have is c to the power of negative 2. Now, I can't leave my expression like this because I have a negative exponent. Remember, we can't leave negative exponents. So to get rid of this negative exponent right here, I'm just going to bring it to the bottom. So my 6ab squared stay up top, but my c squared moves down to the bottom. So my final answer is 6ab squared over c squared. There's nothing else I can do because that's in its simplest form. Okay. The next one is a combination of a few different exponent rules. I have power to a power, I have negative exponents, I have my quotient rule. So to decide what to do first, we're going to think about our order of operations. In our order of operations, we always do exponents before division. So I have to distribute this negative exponent before I can divide. Okay, and if you remember, power to a power says if I have an exponent to another power, I multiply those exponents. So 2 times negative 2 is going to give me a negative 4. So q to the power of negative 4, and I'm going to have r to the power of 3 times negative 2. And 3 times negative 2 is going to give me negative 6. So q to the power of negative 4, r to the power of negative 6, over q7, r to the power of 3. Now I can use my quotient rule, and my quotient rule says when I divide, I subtract my exponents. So I'm going to subtract my q's from my q's and my r's from my r's. So negative 4 minus 7 is going to give me q to the power of negative 11. And then negative 6 minus 3 is going to give me negative 9. So r to the power of negative 9. Now again, we can't have any negative exponents, so I have to get rid of those. So to get rid of my negative exponents, I'm just going to move them to the bottom. Since they're both negative, I'm going to move both of those to the bottom. And all that leaves me on the top is 1. So I'm going to have 1 over q to the power of 11, r to the power of 9. And that's it. I don't have any more negative exponents, and nothing else can be simplified. That's my final answer. Okay. Now, this last question is similar to what we just did, but we have an extra power of 3 on the outside. Okay, now before I can get to this 3 over here, I need to simplify the inside as much as I can. So I need to distribute this power of negative 2 to everything on the inside. And then I need to distribute this power of 4 to everything on the inside of these parentheses. Okay, so that's going to give me negative 2 to the power of negative 2. A to the power to a power tells me I'm going to multiply. 4 times negative 2 is negative 8. Over a to the power of 4. Okay, because it goes to both terms. And again, power to a power says I'm going to multiply. So b to the power of 8. Now, this whole thing is still to the power of 3. And we'll get to that 3 in a second, but before we do, we need to simplify. Okay? Now, to get rid of this negative exponent right here, I'm going to move this negative 2 squared to the bottom. All right? Same thing with this negative 8. I'm just going to go ahead and move that to the bottom. and that will get rid of those negatives. So all that leaves me on the top is 1. So I have 1 over, I move this to the bottom, it becomes -2 squared. Then I have a to the 4th, and then I move my other a down, so I have a to the 8th, and then I have b to the 8th. Again, all of this is still to the 3rd power, and then I'm going to simplify, and then I can worry about that 3rd power. Okay, so -2 squared is going to give me +4. So I have a 4 down here. A to the 4th times a to the 8th. When I multiply, I add my exponents. So it gives me a to the 12th. I don't do anything with that b to the 8th, so it stays b to the 8th. And all I have left on top is still that 1. So now I can finally get rid of this 3rd power by distributing it to everything. So I distribute it to the 1, I distribute it to the 4, to the a, and to the b. And excuse my ugly lines, I'm running out of room over here. Okay, so I have 1 to the 3rd power. 1 to the 3rd power is 1 times 1 times 1, which just leaves me with 1. And then I have 4 to the 3rd power as well. So 4 times 4 is 16. And 16 times 4 is going to give me 64. Okay, so that becomes 64. All right, power to a power means I multiply. So 12 times 3 is 36. So it gives me a to the power of 36. And then multiply again here. 8 times 3 is 24. B to the power of 24. So this simplifies, excuse my computer acting up. This simplifies to 1 over 64, a to the power of 36, b to the power of 24. Okay, and that's all we're going to do with exponent rules today. So like I told you in class yesterday, you do have some practice problems. There's a paper copy with the sub, and I posted it on Google Classroom with these videos, so you can choose how you want to do them. I'm not taking it up for a grade, but you need to make sure you practice some of them, especially exponent problems, because it will be on your test and you will see it again. I'll see y'all tomorrow whenever I get back.